Alright, this is second part of the video of full factorial design analysis in the Minitab. Let's solve it. Go to the stat, then go to DOE, factorial, analyze factorial design. Here go to only in the first part, only go to graphs and select this 4 in 1. Click OK. Don't do anything in the start and then click OK. In the result, to view them, click on this button. You can see the cycle time p-value 0.00, likewise operator, temperature, all of them have value 00. Okay, so when we come towards this two-way or two-factor interaction, only temperature and operator is found to be insignificant, 0.194. Can we delete it? No. Why? Because over three-way interaction or three-factor interaction, that is the interaction of cycle time, temperature and operator, it is found to be a significant one. It means that all of the three combination of all three factors has a significant effect on the response variable. So when your highest level interaction is found to be significant, you can't delete the lower two-factor interaction or the linear terms from the model. Please remember that. Going down, we got our R square. R square value is 91.31. It means that the cycle time, temperature and operator has explained 91.31% variation in the response variable. Rest, the variation of almost, you can say, around 8.69% is still unknown. Coming down, it is showing that the factor A has the highest effect, followed by AC, then C, then AB. If you want to see that how much percentage contribution of each factor or interaction is on the response variable, you will go to again stat, DOE, factorial, analyze factorial design, and here in the result go to the expanded tables. This table will help you more as compared to the simple tables. So if you see there that you will get the percentage contribution of cycle time is almost 32.12%. and likewise you will get all of them, and error percentage is 8.69. that is still, you can say, unexplained. If you want to calculate the percentage contribution while solving the problem by hand, so you will have to do like this: divide the sum of square for interaction or the linear term by the total sum of square. For example, 46.19 divided by 1357.33, you will get 3.40. So these are the four plots. I have clicked all in one, so you can see it here. The data is following somehow normal distribution, and in the histogram it is also clear that the data is normally distributed. From the observation order versus residual, it seems that there is no cyclic patterns, or there are no 6 points continuously above or below this central line 0, and this is the versus fits. It also seems to be equal number of points are above and below this dotted line. So our data is valid and the ANOVA assumption has been satisfied. We can rely on our ANOVA results. After doing ANOVA analysis, we will generate the regression equation. Go to stat, regression, and then fit regression model. Okay, here all of them are already selected. I'm going to delete them so that we can enter the data again. It will be easy for you. My response name is response. Continuous predictors are cycle time and temperature, whereas categorial, so there are operator has three categories, 1, 2 and 3. You can give any operator 1, 2 and 3. So after this, click OK. You will get three regression equation based upon the number of categorical levels you have. So you can see it here that all of the coefficients along with the cycle time and temperature is same in three equation. However, the value of the y-intercept is changing. So you can see that operator number 2, looking at the intercept of the response 2 for the operator number 2, the highest value, it means that operator number 2 is better than these operator 1 and 3. Then operator 3 is better than operator 1. So in this way, if you have a categorical factor, you will get different regression equation, and this intercept will show you that which one of the categorical variable level is better than others. Last thing in the factorial design is creation of the main effects. So go to the ANOVA and then go to main effects plot. It is very important for you people to make these graphs. Select the response and then factors. So select all of them at once, no issue for you people. And if you want to do Individually, it's up to you, no problem. So here you got that we got the response variable value maximum at cycle 2, cycle time level 2, that is 50. Temperature 350 is good for increasing the cycle time, and then operator number 2 is perform very well as compared to operator 3 and operator 1. If, for example, if you want to minimize your response variable, how you will select the levels of the factor? You will say that cycle time number 3, that is 60, temperature level number 1 300, and operator 1 is good in order to minimize the response variable. You can create these graphs quite attractive in the Minitab. I have made a separate video. If you want to that video, please go in the playlist with the title how to make attractive graphs for the research paper, article and journals. After making this graph individual, then again go to ANOVA and the last option interaction plot. Here again select the response and then factor. I suggest you people to select only 2 factors because interpreting these 2 factors is quite easy for you people for the interaction term. So as you can see, the cycle time level that are represented by blue and green. These are 40 and 60. There is a strong interaction for them at temperature when we go from temperature 300 to 350. So we got an interaction. Likewise, you will have to make again go to ANOVA interaction plot in this time, then again go to cycle time and operator. Click OK. You will again get a graph like this. And then for the third 2-factor interaction, again you will have to go. So please do not do it at once. It will create a very mess for you people. However, if you want to do it, then go select all of them and check this option, display full interaction plot matrix. It is again not a good thing, but help you in the research paper that you can input all of the graphs at once. You can see that operator and this temperature, it doesn't have any significant interaction effect because no lines are intersecting each other. So that was all about today's lecture. Thanks for watching the video. Kindly like the video, hit the like button and subscribe to my channel. Bye.